This set of tutorials reviews igneous rocks and mineral size. Now, if you look at these igneous rocks on this page, you'll see that there's a variety of sizes of minerals. The one on the left is a fine-grained rock, it's basalt, but it does have some large visible crystals of olivine, and that's what the green mineral is. And those are phenocrysts, larger minerals in a fine-grained ground mass, but this is a volcanic rock. This is also actually a rock that has a little xenolith in it as well, a little foreign rock that was brought up with the magma, but we're not going to worry about that. On the right, we have a granite. This is a coarse-grained igneous rock. You can see all the different minerals. There's pink feldspars, dark-colored hornblends, quartz, plagioclase, etc. In the middle, we have a porphyritic rock, which has two distinct size populations of crystals. The black area consists of very small, fine-grained minerals, and then these large white crystals of plagioclase are very, very visible. So what gives us all this different kind of texture? Well, the learning objectives are to illustrate why mineral sizes vary in the first place, and then use the size we see to determine where the rock formed. So question 1 and 2 would happen if we were actually in a real classroom. I'd have everyone stand up and do this. So you're going to have to just imagine. So let's say everybody's up in the classroom and scattered about, or maybe we even went outside and kind of got scattered farther from each other than just in a classroom size area. And then I gave you 2 seconds to move together and make groups as big as you could of people. So if you only had 2 seconds, you might have only had groups of 2 to 4 people. If I had you scatter out again, and this time I gave you 10 seconds to make the groups as big as you could, you might have actually gotten the whole class into one big group. So 2 students are debating about how this activity relates to mineral size in igneous rocks. The first student says, "It seems to me that with a longer amount of time, it's possible for all of the atoms to form really large minerals," in which case the students would be the atoms. Student 2 says, "Well, I don't know. I would think that more time means that more minerals will form, and that only a little bit of time would mean that only a few minerals would form, and they would be really big." So which student do you agree with and why? Well, student 1 is correct. And the reason is that minerals start small, and they grow larger with time. So when you have a short amount of time, those minerals just have not had enough opportunity to grow larger. And so student 1 is correct. Part 2 asks you to think about the place where the magma cools and the mineral size. They're showing 2 bodies of magma. One is above ground and the other is below, deep in the crust. They have arrows showing heat escaping, and the length of the arrow represents how fast that heat is escaping. So you can see that in the lava flow, heat is escaping relatively slowly at the base where it's on the ground, but very quickly into the atmosphere. In the deep crust, on the other hand, the magma is cooling slowly in all directions. So the first question asks, which will cool faster? And hopefully it's obvious to you that the lava erupted on the surface will cool faster because of the contact with the atmosphere, which is much colder than the surrounding rocks deep in earth. Granite and gabbro are igneous rocks that have large minerals. They're intrusive. In which location would they have formed? Well, based on what we just looked at, they would form deep in the crust. Rhyolite and basalt, which are extrusive, are igneous rocks that have minerals so small that it's very difficult to see them with the naked eye. In which location would they have formed? And in that case, it would be on the surface. Question 7 asks you to circle which of the 2 rocks in these pictures formed in the deep crust. And I hope that even if the names of the rocks were not given, you could figure this out, because you would look for 2 rocks that have large crystals. Granite and gabbro, in this case, have very large crystals that you can see. Rhyolite and basalt look like one uniform color, and so those are most likely volcanic with very small mineral grains. Analysis of a porphyry. So remember that a porphyry has 2 different size populations of crystals, some that are big and some that are small. There's a picture of a porphyry on the right. We've got some large rectangular white minerals, and then we've got some large black minerals that are in some cases a little rounded, but in other cases somewhat elongated and flat. And then the gray all around it, which we call the ground mass, is what's fine-grained. We really don't see individual minerals there. So students are debating the formation of these two different mineral sizes. Student 1 says this rock formed because large pieces of sediment got picked up in lava and they didn't melt. Then the lava cooled quickly at the surface to form these small minerals. Student 2 said this is an igneous rock, so everything started off as magma. The large minerals formed slowly and deep underground, but then the rest of the rock, containing the small gray minerals, or gray in this picture at least, cooled very quickly at the surface. So which student do you agree with and why? Well, student 2 is correct, and that's because the visible minerals are showing their crystal shape. They're not pieces of sediment. Finally, student 2, who was correct, says that the large minerals formed in a magma chamber deep underground, and then the rest of the magma cooled quickly at the surface to become the small minerals of the ground mass. Describe how a volcano played a role in forming this igneous rock porphyry. Well, a volcano erupted and it brought a partially crystallized magma to the surface. So in that magma chamber, we had these white and black minerals forming, and then it was erupted, and the surrounding material that had not yet crystallized solidified very quickly.